Hello everybody, welcome to another episode of Coding with Culp. Today is a great day to learn how to code. So today we're going to start messing with Pygame. Pygame is a game programming library specifically written for Python. It allows you to load graphics, sound, animation, detect collisions, joysticks, all sorts of other stuff. Basically it's all the tools you'll need to make games with Pygame. So our learning goals today is that by the end of this video, I want you to be able to initialize Pygame, open a Pygame window, set the caption or the title of that window, be able to draw to the Pygame window, understand the main game loop, understand how to use functions. We're going to be functionalizing most of what we do. Oh, I've got to understand the main game loop in there twice. I guess it's that important. I want you to understand how to animate actors on the screen. Understand the Pygame coordinate system, be able to detect collisions between game objects, and load images and move them around. This tutorial will by no means make you an expert on Pygame, but it'll be able to get you started. We're actually going to make a game. By the time we're all done with this tutorial, we'll have a simple little game. It's not a very good game, but it is a game all the same. So without further ado, let's go ahead, let's get started, let's write some code. Okay, as always, I'm going to be using a Raspberry Pi 4 for this, and I'm going to be using a integrated development environment called Genie. It's really super lightweight, really good IDE. What I like about it is it does just enough for you, and especially if you're just beginning to code, it doesn't really get in your way. It does just enough. So I'm going to fire up Genie here, and I've got starts out with a new file. I'm going to come over here and go File, Save As, and I've got a little coding directory here, and this is going to be called Hello Pygame, and I'm going to save this as hellopygame.py. Make sure you get the .py in there so Genie knows it's a Python file. I'm going to click Save and Replace. Okay. So the first thing we've got to do in any Pygame file is we got to import Pygame. Next, we're going to set up our Pygame variables and constants. Now, if you're not familiar with what this hashtag right here does, it is a comment. It doesn't actually get executed by the code. It's just for us. It's basically to tell us, the programmer, or whoever might be reading our code, what this does. So what I'm going to do is I'm going to mess up here. Okay, here we go. I'm going to set the screen width and height of what's going to be our window. I'm going to make these variables so that if we ever need to change them, we can change them quite easily without having to go and change it in 50 different places that we might use this information. I put them in all capitals because technically they are constants. We're actually not going to change them on the fly as we are playing the game. We might change them later on if we decide, hey, we want our window to be bigger or smaller. So traditionally in programming, constants that we're not going to change during runtime are in all capital letters. All right, so our screen width and screen height are going to be 750 each. Now, I'm going to set up some game constants, some game state constants. We're going to use a state variable to keep track of our game, whether it's running, whether it's in the process of quitting, and there's all sorts of other stuff we could use. For example, we could have a paused game state. So we're just going to use a couple of constants to keep track of that. So we're going to do game state running equals 0, and game state quit, if we want to quit the game, equal to 1. You'll understand this here in just a bit when we actually start using it. And game state equals game state running. So essentially, I could have set game state running to be anything. I could have set it equal to this if I wanted to. The number doesn't matter as long as it's different from game state quit. And so what we do is we have a state variable. whoops. And that state variable I called game state because it's going to hold the state of the game right now. And I set it initially to game state running because we're going to start off running the game. And what we're going to do as we play the game is we're going to check, and if the game is over, we're going to set game state to game state quit. And then our main loop is going to act on that information and stop the game. All right, so now let's actually start Pygame. Start Pygame and set up the drawing window. So now we're actually going to be able to do something. All right, so before we can actually do anything with Pygame, we have to initialize it. And that function is init. If I spelled it right. And I still can't spell it right. All right. So pygame.init starts Pygame. Now what we're going to do is we're actually going to set our drawing window. And I'll explain this line in just a second.
Set mode.
Okay, there we go. So what this does, we set a variable called screen that's going to hold our drawing object, the object we're going to draw into. I could have named this anything. You'll sometimes see it called display. I call it screen. I could have called it anything. And the function to initialize that is pygame.display.setMode, and we pass to it, and this is important, common error. We're going to pass to it the screen width and screen height. Notice that screen width and screen height are themselves contained in parentheses. This is essentially what we call in Python a tuple or a tuple, depends upon how you want to pronounce that. But it must be the screen width and screen height must be in parentheses themselves. Now, I could have hard coded this. You know, I could have did 750, 750 if I wanted to. And you'll see it written this way in many places. But I don't like to do that, as it's really good to be able to reference the screen width and screen height, as you'll see later on. And if I just wrote 750 and 750, 100 places in the code, if later on I decided, well, I really need my window to be 900 by 900, I'm going to have to go change it in every one of those places. Whereas by setting a couple of constants like this, the only place I'd have to change it is right up here. Now we can actually go ahead and run this. So let's run it. And it doesn't really do much. There we go. Uh-oh. Oh, yeah, it doesn't do much. If you saw that, it actually started up the Pygame window, which is right there. There it is. Hello, Pygame, and then quits. So it doesn't actually do much. Now, we can start up what we call our main game loop. In fact, I'm going to main game loop. So we can say while game state equals game state running. In other words, while this game state variable, while it holds the value of game state running, while the game is running, do our main game loop. First thing we're going to do in our main game loop is we're going to check for events. So what we do is we're going to go into a while loop, and we're going to keep executing everything that's in this while loop. And this is where our main game loop is going to go, and as you'll see in just a minute, we'll call functions to draw to the screen, to detect collisions, and do quite a bit of other stuff. But for right now, the only thing we do is we are going to scan for events. What this does, pygame.event.get, is going to get the next Pygame event. And events are stuff like the user has pressed a key, or move the mouse, or click the little red X to exit out of Pygame. And in fact, that's the only event we're going to check for. So what we do is we say if event.type, if that's equal, remember double equals test for equality, if it's equal to the pygame.quit, event, we're going to set our game state to game state quit. And there's one last thing I got to do. Let's see here. Pygame.quit. So what's going to happen is, if Pygame gets the quit signal, it's going to set game state to game state quit. The next time it comes up to here, this test is going to fail because game state will not be equal to game state running. It will be equal to game state quit. It will then exit out of the while loop and come down here and execute pygame.quit, which then quits Pygame and exits the program. Now let's run it. See what happens. And there we go. Uh-oh, I've got an error. Event is not defined. If event.type. Alright, let's take a look and see. Where did I go? For events in Pygame, really what I wanted to say was for event in Pygame. Because this variable right here gets the current event, and then we check to see what its type is right there. Now let's give it a try. Alright, ta-da! It worked. So you can see, we set the caption right here. We set it to Hello Pygame. I could have done anything, and this would be right here, and it would have set the caption. So now to quit, all I got to do is click the X, and our little event loop is going to get the quit event. It's going to set game state to game state quit, and exit. And there we go. All right, that's all fine and dandy, but it doesn't do a whole lot. So let's draw into our window. And so the first thing we want to do, I want to change the background. And screen.fill will fill with a color. Let's make it white. And I'll explain color in just a second. Okay, screen.fill takes 3 values. Now notice, once again, these 3 values are themselves inside of parentheses. It's a tuple or a tuple, however you pronounce it in Python. People pronounce it differently. It takes 3 values, a red, a green, and a blue. These values can range from 0 to 255. What that means is the amount of that particular color you want in your overall color. For example, in this, we have equal amounts of red, green, and blue in their full intensity. So it's going to be completely white. If I wanted it to be all red, I could set it with 255 red and 0 green and 0 blue. So let's run it. Let's experiment around with that for just a second. Oh, I forgot something super important. You're probably like, well, it's still black. It is, and that's because I forgot something. What we got to do, no changes are made. Python, let me type this out. Why did I make it a comment? Okay. Python actually draws to a background buffer, a hidden buffer, basically a hidden screen. And none of our changes are shown until we do this pygame.display.flip. That's to prevent screen tearing and some other artifacts, and to make our game animation a little bit smoother. So we draw everything to a background screen that's not shown. Then we flip the display, and the display that we see is flipped to the background, and the background is flipped to the front. So now it should work. Looks like I didn't run it. Hang on just a second. Let me get rid of some of these terminal windows. Okay, let's give it a try now. There we go. And ta-da! We have a white background. And as I said, we can experiment. Let's do full red, no green, and full blue. Let's see what we get. Let's do maybe half green and only a little bit of red and full blue. Let's see what we get. There we go. let's reduce the amount of blue to maybe, let's go equal amounts of green and blue. You can experiment around with this all you want. There we go. All right, Genie actually has a color picker built in, and it's going to tell you the red, green, blue values. For example, let's say we wanted this yellow right here. There we go, bright yellow. It's going to tell us we need 234 red, 244 green, and 15 blue. So 234, 244, 15. 234, 244, what was it, 15 I think? And let's run it. Should be bright yellow now. And there we go. So Genie has a color picker built in, so you don't have to guess at the values. You can actually find them directly. Okay, let me go back to white. And most colors in Pygame are referenced this way with a red, green, blue value. That is, once again, in those parentheses. Okay, so that's great, but let's draw something in our window. We're going to draw a circle. And the function to draw a circle is draw dot circle. And why do I keep typing a comma here? This takes a couple of values. So the first thing it's going to take is, where do we want to draw it to? We want to draw it to the screen. Okay. Now remember, screen is a variable that we set up right up here. It's a variable we set up right up there at the top. I could have called it anything. Had I called it, I don't know, I'm going to go with something crazy here. If I called it Luke Skywalker. I would have to write Luke Skywalker right here, because that's where we were going to draw it to. But because I don't want it to be Luke Skywalker, I'm going to keep it a screen. All right, so the first parameter is where we want to draw it to. The next one is the color. Once again, notice the color is surrounded in parentheses. And I'm going to make it full blue. Next is where we want to draw it to. Now I'm going to use a couple of variables that we have not used yet. I'm going to use something to keep track of the balls X and Y. So let me come up here. I'm going to say setup, actor, variables, and constants. And we're going to have a ball X. And at the beginning, we're going to set ball X equal to screen width divided by 2. And notice that the double division sign, I didn't make a mistake there. The double division sign in Python is integer division, so it won't be a floating point number. Because there's a possibility if we divided by 2, if screen width was an odd number, that we'd end up with ball X being a floating point number, and that's not what we want in this case. So this is going to guarantee that it is, in fact, an integer. Then we got ball Y equals, let's see here, screen height, once again, divided by 2. So this keeps track of ball X and ball Y, or it keeps track of our X and Y values for a ball. So now we run it. It should be pretty boring. We should have an error. What did I do? Aha, bay YY, or bay Y, ball Y. There we go. Let me get rid of some of these terminal windows here. I always forget to do that after running something in Genie. All right, are we going to work this time? We are not. We're going to get another error. Let's see. Pygame.draw.circle function takes at least 4 arguments, but I need the radius of the ball, the circle. The radius of the circle. And once again, let's not hard code that. Let's make a variable to keep track of it. And let's make a radius of, I don't know, 20. So right here, ball radius. Ta-da! It worked finally. So let's talk a little bit about screen coordinates with Pygame so you can understand those. Okay, so I got a little graphic here that illustrates Pygame coordinates and most graphic coordinates for that matter. The rectangle or the square represents the screen. The upper left is coordinate point 0, 0 in the order of x, y. X values increase going from the left to the right. This coordinate up here would be 749, 0. Now you're probably going, wait a minute. Our screen width was 750, not 749. But remember, we started out at 0. So that is, in fact, 750 pixels. So this would be 749. Our x value is 749. And our y value is 0. Don't worry about these circles. I drew them for something else I'm going to show you in just a bit. Our y values increase going down. So y values increase the further down the screen we get. That throws some people for a loop because it seems opposite of what it should be. All right. So because of that, this point over here is 0, 749. In other words, the x value is 0 here because we haven't traveled along the x-axis. And our y value is 749 because we're at the bottom of the screen. And then over here on the right, it's 749, 749. So now what we'd like to do is animate it. So we're going to move to part 2 of this video, animating the ball. All right, welcome back for part 2 of Pygame Basics. In part 1, we wrote a basic Pygame program. All it does is display a window, and we drew I think a blue ball in the middle of it. What we're going to do is we're going to start animating that ball. So in part 2, we're going to learn to animate the ball, and then we're going to learn a little bit about player control. We're going to put another object on the screen and give the player control of that object. So let's get started. We're just going to pick up where we left off on part 1. Okay, so animation is pretty simple. All we really have to do is in our game loop, all we have to do is change the, what have I done here? Let me press Control Z a whole bunch of times. All right, all we have to do is change the ball's x coordinate and the y coordinate each time through the loop, and the ball is going to move. What I'm going to do is I'm going to make 2 variables. Whatever I did, I erased the... Okay, no, this is correct. I'm going to make a variable called, let's say, ball delta x, and we're going to set equal to 2, and ball delta y, and set it equal to 3. So it's going to move faster in the y direction than the x direction. These 2 variables, all they're going to do is keep track of basically the speed of the ball, the speed in the x direction and the speed in the y direction. Delta is kind of a term for change. So basically this means the change in the x direction and the change in the y direction. Once again, these are variables. I could have named them anything I wanted. I could have named it ball x speed or ball x velocity or something. I chose ball delta x and ball delta y. So before we draw, all we have to do is say something along the lines of, well, let's see here, ball x equals ball x plus ball delta x. And then ball y equals ball y plus ball delta y. That should be all we have to do, and it should move our ball. Let's find out. And there we go. And it worked. It moved off the screen because we don't have any means of checking its bounds yet. But there it goes. Okay. Now we're going to learn to start putting stuff into functions. In our main game loop, we shouldn't actually do a lot. We shouldn't have a lot of our game logic in the main game loop. We should set them up in functions. So I'm going to have a function called move actors. So way up here at the top. Yeah, way up here at the top. I'm going to make a function and I'm going to call it, actually it's called move game objects. And what I'm going to do is I'm going to move that code that changes our ball X and our ball Y. Control X. And I'm going to put it right up here. And now we're about to learn a super important lesson in Python. So what this is a function. We can call our function just by simply naming it. Move game objects, open and close parentheses. So what's going to happen through our game loop, it's going to check for events and act on the quit event if we have it. It's going to fill the screen with white. And then it's going to call our function move game objects. So it's going to go all the way up here. Whoops, all the way up here. And it's going to move these game objects. So it's going to do the same thing. It's going to take ball X and add ball delta X to it. So ball X is going to be equal to the old value of ball X plus whatever ball delta X is. Which I think, what we set it at 2. And same thing with ball Y equals ball Y plus ball delta Y. This seems like it should work. Let's run it. I'm going to tell you that it's not going to work. Oh, we got an error. Let's figure out what that error is. It says ball X equals ball X plus ball delta Y. That there's an unbound local error. That local variable ball X is referenced before assignment. And it's in line number 4. So let's take a look at line number 4. That's this line right here. What you're probably saying is, wait a minute. What do you mean an unreferenced variable? We clearly made a variable called ball X right down here. And in fact, it worked. We've already tried out this code. Here comes an important concept in Python that you need to understand. Ball X, ball Y, and in fact, all this stuff right here, all these variables that we have made, are what we call global variables. Whenever we create a new variable, let's say inside of move game objects, it's a different variable than these right here. So it thinks ball X is a brand new variable. And because we've never actually referenced it before, we didn't say something like ball X equals 0 to initialize the variable. In fact, if I run it, let me do this. Now this code is going to run. It's going to work. But you notice it's not moving. And that's because this ball X and ball Y only exist inside of this function. Those are called local variables. And it's a difficult concept to wrap your head around. Now here's the deal. I can reference these global variables. So you're probably going, well, wait a minute. Why didn't we get a error with this? So here's the weird thing about Python. As long as we don't assign something to that global variable, like we're doing here. Ball X is a global variable because it's defined outside of a function. Okay? Ball X is a global variable. That function can read ball X or ball delta X, but it cannot write to it. Okay? Now, Python includes a keyword called global. So global, and if we declare ball X and ball Y as global, now inside of this function, it will be able to write to ball X and change its value. Let's give it a try. And it worked. Okay, there's one other thing I want to show you before we move on, and that is frame rate. So when you run this, depending upon the speed of your computer, it can run really fast or so fast that it goes off the screen really quick. So what we can do is we can set a frame rate. So right over here, I'm going to go, let's see if I can remember how to do it. Okay, so let's see here. Right here, I'm going to set a variable, and we're going to call it clock equals pygame dot time dot clock. And at the very end of my game loop, I'm going to do the following. I am going to do clock dot tick. And inside of here, I'm going to put the frame rate I want to set. So now our game will never run faster than 60 frames per second. That's the fastest it will run. Now here's the deal. If your computer is really slow and you have a lot going on, it may very well run slower than 60 frames per second. But it's not going to run faster than 60 frames per second. Okay, we're going to make one more function before we move on. I don't want to do all my drawing inside of my main game loop. Really what I want to do inside my main game loop is I want to call functions that do other things for me. So I don't want to put a huge amount of code in my main game loop. So I'm going to write a function and we're going to call it maybe draw game objects. How about that? Let's see here. Let's call it draw scene. Oh, I forgot to explain functions. I'll do it here in just a second. So what we're going to do is we're going to move this right here and also our screen.fill into it. So there we go. And our screen.fill. So our main game loop is getting much cleaner. And all we have to do is call draw scene. So what we're going to do is we're going to move our game objects, and then we're going to draw scene. Let's see if it works. And it does. Perfect. Okay, let me explain functions. Functions are blocks of code that you can call by name. In Python, you start a function with def for define or define function, then the name of that function. We're not going to pass any parameters to these functions. No, in other words, not going to pass information the functions can act on. We might do that later, but not right now. So we're going to use an open and close parentheses and then a colon. Then everything after that function definition line that is indented will get executed one line at a time. So in our move game objects, we declare ball x and ball y as global variables. And then we're going to take ball, we're going to execute this line. We're going to add to, we're going to set ball x equal to whatever the old value of ball x was, plus ball delta x. And same thing with ball y. We're going to set ball y equal to whatever the old value of ball y was, plus ball delta y. So that's perfect. Now we've got an issue. And that issue is that our ball goes off the screen. We want it to bounce around the screen. So we want it to bounce around the edges of the screen. So let's check. Let's check for collision. So after we move our ball, here's what we want to do. We want to see if the ball is near one of the edges of the screen. And if it is, we want to change our ball delta x or ball delta y to be opposite or negative of what they were. And that's going to cause the ball to move in the opposite direction. So we just need a bunch of if statements. So I will write it and then I will explain it.
Okay.
I've got one line that checks the x coordinate of the ball. Let's take a look at what we're doing. We're saying if ball x, if the x coordinate of the ball, and that's the center of the ball actually, is less than the ball radius, less than or equal to ball radius, or ball x is greater than or equal to screen width minus ball radius, swap or make the ball delta x the opposite of what it was. So what this does is it multiplies by -1. So if it was positive before, it's going to be negative. If it was negative before, negative times a negative is a positive, it's going to make it positive. Let's run it real quick. It's only going to change in the x direction. I'm not sure if it's going to hit a x first or not. Oh, we got an error. Oh, I fell into the trap. I forgot to call or declare ball delta x as global. So it is basically, hey, I've never heard of this thing before, and you're trying to write to it. Okay, let's see. Nope, we don't hit the X side of the screen. Let's also do the Y. And then we're going to check the Y bounds, which is going to be if ball Y is less than or equal to ball. It's going to be almost the same code, ball radius, or ball Y is greater than or equal to screen height minus ball radius. Then ball delta Y equals ball delta Y, negative ball delta Y. All right, let's give this a try. Oh, I got to declare ball delta Y as global. I got an error. All right, if ball Y, all right, line 10. Syntax, invalid syntax on line 10. So let's see what we got. Line 10. If ball Y is less than or equal to ball radius, radius, or let me just check it. Ball Y is greater than or equal to screen width minus, or screen height minus ball radius. That looks right. Let's try it. There we go. And it works. It's now bouncing around the screen. All right, let's take a look at a quick graphic that kind of shows you what's going on and what this code does graphically. Okay, so this right here represents the ball. This right here represents the radius of the ball, which we set for 20. We can't say if the ball's x-coordinate is less than 0 or less than or equal to 0 because we're referencing the center of this circle. And so what we're saying is if its radius is less than or equal to 0, or excuse me, if its x-coordinate is less than the radius of it, we know that it's moved off the screen, or it's starting to move off the screen in the x direction. Or if its radius is greater than our screen width minus radius, it's starting to move off the screen. Same thing with the y-coordinate. If the y-coordinate, if the x value, or excuse me, the y value, if the y value of our ball is less than the radius, we know that the ball is moving off the screen. So we don't want that. So when we do our checks, we want to check that its x value is less than or equal to the radius. And if that's true, we know it's moving off screen and we need to bounce it. If its x value is greater than our screen width minus radius, we know it's moving off the screen. And same thing with our y values. If the y value is less than radius, less than or equal to radius, we know that it's hit this edge. And on the bottom, if its y value, which would be this point right here, if its y value is greater than the screen height minus the radius, we know it's moved this way. And so that's what that bit of code does. So let's go back and take a look. Okay, so that's what all this does. If ball x, if the x coordinate is less than or equal to the radius of the ball, we know that we're moving off screen on the left side. Or if ball x is greater than or equal to screen width minus ball radius, we know we're moving off the right side. And the same thing here. This checks for the top, and this checks for the bottom. One thing we might do to make our code a little bit clearer is put this check right here in parentheses. In some languages, it is absolutely required. In Python, it's not. But it just makes it easier to read. Easier to see what's being checked for. So I'm going to go ahead and do that. Okay. So now let's add a player to the screen. So basically something that the player can move around. So let's see here. Game state running. Let's put it right here. Set up actor, variables, and constant. So let's just copy and paste this. Control C. And we'll just rename stuff. Remember, programmers are lazy. We like to rename stuff. And we're going to call this player X. And we're not going to start in the middle of the screen. We're going to start in the upper left-hand corner. Let's start at 2020. How about that? Okay, let's see. And we'll just change all this to player. Now we're not going to need a delta X and delta Y for player. We're going to move them with the keyboard. I'll show you how to do that in just a second. We'll keep the radius the same. Okay, so I think that's everything we need for the player. So up here in our draw scene, we're going to need to draw the player. So I'm going to copy and then paste. So Pygame draw circle screen. It's not going to be ball X. It's going to be player X and player Y. And instead of ball radius, it's going to be player radius. And let's see if it works. And it does. I'm going to make the player a different color though. Let's see, what should we do for the player color? Let's just pick something out. I like this green. Let's make it maybe a dark green. And medium. Ooh, no, I like I'm going to go with a purple. 204, 27, 206. Let's just go 206, 27, 206. So 206, 27, 206. There we go. Now you notice we can't move the player around. So let's change that real quick. All right. So what we can do is in our main game loop, we move game objects and we draw a scene. What we can do in move game... No, let's not do that. Let's not do it that way. Let's... how can we do this? Yeah, let's do it in move game objects. I think that's the best place to do it in. Okay, I'm up here in the move game objects function. And what we can do, Pygame has an interesting way that we can read the keys of, or what keys are being pressed right now. Pygame.key.get pressed. Okay. What this line of code does is it essentially returns all of the values of the keys on the keyboard and whether they're pressed or not pressed into a list called keys. I could have named this, once again, anything I wanted to. I could have called it key values. Doesn't matter. I'm going to call it keys. Then what we can do is we can check the value of each one of those keys. So we can do this. Let's do it right here. This will work. We could say if keys Pygame dot k left, and I'm going to link down below a place where you can get the value of all the keys. So if you want to know what they are, so if the user, the player, is pressing the left key, what we want to do is we want to say player x minus equals. Oh, actually, let's do this. Yeah, we're going to make a delta x, delta y. Player delta x. And then if keys Pygame dot k right, if they're pressing the right button, we're going to move to the right. So player x equals plus equals player underscore delta x. Then we're going to check in the y direction if keys Pygame dot k up. Whoops. Player underscore y. Since we're moving up, we're going to be going in the negative direction because up is less. So it's going to be minus equals player underscore delta y. And then finally, if keys Pygame dot k down, player y plus equals player delta y. In addition, because I'm changing the player x and y, I need to put them in my global list. Player x and player y. Now I'm going to scroll down here. I need to set a player delta x and player delta y. They're going to be the same thing. Player delta x equals, I don't know, let's call it 3. And player delta y also equals 3. All right, let's run this, see if it works. Let me get rid of all my excess terminal windows that I always forget to close. All right, here we go. Is it going to work? Oh, we got an error. Let's see here. Pygame is not defined. So that's on line number 10. So let's head up to line number 10. Pygame. G-A-M-E. All right. Let's try it one more time. And there we go. Woohoo! It works. Okay, now notice though, I can move off the screen, and we might not want that. We might want to constrain our player to the edges of the screen. Well, it's going to be very, very similar to this code right here. Only what we're going to do is instead of setting the delta x and delta y, is we're just going to reset their x and y values. So if player x is less than or equal to ball radius, or actually we're going to have to do this a little bit differently. We can't copy it completely. Okay, so basically if the player x, if they're on the left hand side of the screen, so if they're on the very left hand side of the screen, they're trying to keep move and they're wanting to keep moving, we want to set their player x value equal to player radius. And if player x is greater than or equal to screen width minus player radius. We want to set player X equal to screen width minus player radius. There's actually a better way to do this, but I think this is easier to understand. All right, let's do this. Let's just test this in the X direction, make sure it's going to work before we add the Y direction. Okay, I should not be able to move off the left-hand side screen. And I don't know if you can see this, but I am touching the left button, and it's not working. I'm moving to the right. And there we go. Perfectly. Okay. So I'm just going to copy and paste this and turn it into code for the player Y. So if player Y is less than or equal to ball radius, player Y equals player radius. And then if player Y is not screen width, we want screen height. And screen height okay, let's give it a try. All right, it's working. Perfect. Okay, so now we get the basics of a little bit of a game. Let's make it like this is a mouse chasing cheese. So we're the mouse, and the blue circle represents cheese. And every time we hit it, we get a point, and then it randomly resets the position of the cheese. And maybe we'll have 10 seconds to get as many points as possible. So that's going to be our game. I told you it wasn't going to be a great game, but it is a game. So what we're going to need is we're going to need to keep track of our score. So let's do that when we set up game state constants and game stuff. Yeah, let's do game score. Equals 0. So then, in our collision detection, remember what I said? We haven't detected collisions yet. So what we need to do is we need to be able to tell when the two balls have collided. And that's actually pretty simple for circles. And in fact, it's one of the reasons why I chose circles, is because figuring out if two circles have collided is actually quite simple. So now let's take a look at a little graphic that I have set up. Okay. Detecting if two circles have collided is actually incredibly simple. Let's pretend for a minute these are two circles, and I drew them of different sizes to illustrate a point. It doesn't matter if they're two different sizes. Essentially, the two circles have collided if one circle interlaps the other. And we'll know that if that's true, if the distance between their centers, the center of this one and the center of this one, is shorter than their two radiuses added together. So if they're just touching, R1 plus R2 represents the distance between them. However, if this one keeps moving, let's say this one's moving into this one, the two radiuses added together, the R1 plus the R2, is going to be greater than the distance between their centers. And we can find the distance between the 2 points with this formula down here. It's just the distance formula. If you have geometry, you're probably familiar with this. If you haven't, don't worry about it. Just know that this works. The distance formula to find the distance between 2 points, it's just the square root of their x values added together and squared, plus their y values, subtracted, x2 minus x1 squared, plus their y values subtracted squared. So what we're going to do is we're going to take the x values of the two circles, and we're going to subtract them and then square it. Then we're going to take the y values, subtract them, and square it. We're going to add them together and then take the square root. So let's do that in some code real quick. Let's make a function to do this for us, because once again, I like functions. We're going to call it, because it's detecting collisions, detect collisions. Okay. That was a pretty complicated math formula, and we could do it all in one line if we wanted to, one giant line of Python. I'm going to break it up just to make it easier to read and maybe make it easier for you to understand. So remember, to get the x terms underneath the square root value, we simply subtract the x values. So that's going to be player x minus ball x. And then we square it, which is just our x terms. Whoops. X terms equals x terms. Wow. Times x terms. Okay. So we subtract the two x values, and then right here we square it. We take x terms, whatever's in x terms, multiply by x terms, and basically reset this value right here. We're going to do the same thing with y terms. So I'm going to say Control-C. I'm going to then just change this. Once again, programmers are lazy, especially lazy typers. Okay, so that's got that. Now what we have to do is we have to take the square root of that. We're going to need a square root function, and that's contained in the math module. So up here at the very top, I have to import math. All right, so I'm going to import the math module because it has a square root function. And then I'm going to come back down here in my detect collisions, and I'm going to say distance. This is where I'm actually going to calculate the distance. Equals math.sqrt, stands for square root. And it's going to be the square root of the x terms plus the y terms. That's right. Now, I'm going to say if distance, the distance between them, is less than ball radius plus player radius, I'm going to explain what this is in just a second. Return true, else return false. Okay. And I'm going to put this in parentheses. Don't need it. It just clarifies things a little bit. So what we're going to do in our detect collisions function is we are going to find the distance between the two circles using our distance formula. Then we're going to say, hey, if the distance between those two circles is less than their radiuses added together, return true. Let's spell it properly. Return true. So this function is actually returning a value that we can act on, and I'll show you how to use that in just a second. Otherwise, they haven't collided and return false. Let's go down to our main game loop. All right. In our main game loop, we can actually detect or use our detect collision function. So what we're going to do is we are going to move our game objects, and we're going to look for collisions. We're going to say if detect collisions equals true. In other words, if detect collisions, we'll call the detect collisions, it'll come up here, run the detect collision code, and it's going to return a value. It's going to be true or false. If that value that is returned is true, they have collided. We're going to do game score plus equals 1. By the way, I don't know if I've explained this plus equals stuff before. It's just a shortcut to say game score equals game score plus 1. It could actually be plus 2, plus 20. Doesn't matter. It's just a shortcut. Plus equals 1. We're going to add 1 to our score. And what we're going to do is we're going to reset the ball into a random spot on the screen. So we're going to need the random module. I'm going to come up here at the top. I'm going to say import random. Let's come back down to here. If detect collision equals true. Game score plus equals 1. All right, ball X equals random dot randint. The range is going to be ball radius to screen width minus ball radius. I'll explain this in just a second. And then ball Y is going to be almost the same code. So I'm just going to copy and paste it and just change a couple things. Ball Y is going to be equal to ball radius, and instead of screen width, it's going to be screen height. All right, I think that's it. So our main game loop now. We're going to check for the quit event. We're then going to move some game objects. We're going to move everything on screen. We're going to detect if any collisions occurred during those movements. If a collision has been detected, we're going to add 1 to our game score, and we're going to reset the ball's X and Y position to a random position. Then we're going to draw the scene. We're going to display flip. We're actually going to display it. And then we're going to cap our frame rate to 60. All right, let's see what happens. Be a miracle if it works. All right, looks like it's working. Yep, every time I hit the blue circle, I'm chasing it around here. It resets. Okay, that's awesome. That's good. Okay, that ends part 2. We'll be back in just a second for part 3. In part 3, we're going to learn how to put text on the screen so we can display our score. We're going to put a timer on the game so that you have 10 seconds to get the highest score possible. All right, welcome back to part 3 of Pygame Basics. So to recap, we have a Pygame application. It's got a little blue circle that bounces around the screen, and we've got a pink or purplish circle that the user can move around. We can detect when the two circles collide, and we give the user we add to the score. So what we're going to do in part 3 is we're going to display the score. We're going to add a timer so that the user has 10 seconds to score as many points as possible. Then the game will exit and display the score for the player. So let's get started coding again. Okay. So what we want to do is we want to display our the user's score. And we're going to do that in the draw scene function because it's part of drawing the scene. In order to do that, we have to make what's called a font object in Pygame. So let's come over here where we set up all the Pygame setup, and let's do this. Let's call our font. I could have called it anything I wanted to. It's just a variable, technically. All right, so font equals pygame.font.sysfont. So we're going to use the system font called Comic Sans MS. Yeah, I think this is how we spell it. And we are going to use 48-point font. So what this does is it creates a font object that we can use. And the function calls pygame.font.sysfont. We put the name of the font here. So I'm going to use Comic Sans MS and the size of the font. Now, we need to use this. So let's go up here to our draw scene function. So what we're going to do in draw scene is we are going to, oh, wait a minute. All right, so all we're doing right now in draw scene is filling with white, drawing the player. In fact, let's put in a couple comments here. Let's see, this is drawing the ball. And this is going to draw the player. Okay. So what we have to do, this gets a little bit complicated, and it's not too complicated, is we need to render a font into an image. In other words, we need to draw, into an image object with that font. I think it's easier to take a look at in code. All right, so the first thing we're going to do is we're going to do the score. Text equals font.render. And I will explain the code in just a second. And then I think it's color next. Yeah, I think this is right. We'll see if I'm right in just a second. Okay, so here's what this does. We're going to create a object. It's going to be an image object, actually, with font.render. What render does is it draws this text in this color and makes it literally an image. And we use the blit function of screen.blit, to draw this image object at this coordinate, 10, 10. So it's going to be up in the upper left-hand corner. So once again, oh, and let me explain this right here. Remember game score? Game score is a number. And font.render is expecting the first parameter to be text. And since game score is a number, we're going to convert it to a string variable or a string object with the str function. So that's going to convert it into text. And we're going to draw it in this color right here. Now don't forget, and for now, just make the middle parameter true. Then the blit function draws an image into our screen object. And the image is named text because that's what we did right there. And it's 10, 10. That's the XY. Let's run it. All right, so our score is 0. And let's see here. Our score is 1. Our score is 2. 3. Am I going to hit it? 4. 5. Okay, awesome. That works. I'm going to change it just a little bit. I'm going to say score so what that's going to do is going to concatenate or add together the text score and the text that game score gets converted into. And there we go. Notice something, that score is on top of our player object. And that's because of the order that we drew things. We're going to draw the ball object, the player object, and then the text gets drawn on top of everything else. All right. So this is working. This is great. The only problem is we're going to play forever. And in fact, let me let's come down here, the very bottom, and before pygame.quit, let's print out into the console window, your score was plus, once again, we're going to convert game score into a text object. So it's going to print a score. All right. So here's the problem. The game never ends. We'll just keep going and going and going. Let's give the user 10 seconds, okay, 10 seconds in order to score as many points as possible. And we can do that by keeping track of a time object. So let's import the time module. It's the very top. Now, just before we go into our main game loop, what we can do is we can say game start time equals time dot time. What that's going to do is it's going to get the current time. And we can say game end time equals game start time plus 10 seconds. So essentially, the game is going to end 10 seconds after the game start time. Let's write a little function. The last thing we're going to do after draw scene, the very last thing we're going to do after draw scene is we're going to check game end. So we're going to check for the game end. We're going to write a little function up here. Def check game end. And all we're going to say in check game end is if the current time dot time is greater than game end time, game state equals game state quit. Oh, I'm writing to game state. I'm changing it. Game state is a global variable, so I need to make sure I declare that. Okay. So let's get a handle on what we're doing here. Every time through our loop, the very last thing that we're going to do after we draw our scene is we're going to check and see if the game is over. And so what it does when that function gets called is it just says, is the current time, is the time right now greater than our game ending time that we calculated? And if it does, or if it is, it's going to set our game state to game state quit. So then when it goes back up to the top, game state, that variable is no longer equal to game state running, and so it quits. And it's going to print out our score and end the game. In reality, I could have done this a little bit better. Really, all I really need to do is say game end time equals time dot time plus game start time. Oh, I'm sorry. Plus 10. That's all I really need to do. I didn't need to make a variable called game start time. However, I'm going to keep it the way I had it before. I'm going to go back a little bit. I know it might seem a little bit less efficient, but sometimes you never know. We might need to know the game start time. So just in case, I'm gonna keep it that way. I'm also gonna put a space there to make that a little bit easier to read. All right, let's give this a try. So our game should last no more than 10 seconds. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000. 8,000. Oh, there we go. My count was off. So it ended, and right here it printed out my score. My score was 2, so I got 2 points. Well, no, it's not the final thing we're going to do. It would be good if we could print out the time remaining. And we're going to do that in our draw scene function. So all we have to do is print out the time remaining. So, okay. Let's do this. Let's calculate the time left. We know the time left is going to be equal to the current time time left is going to be equal to the current time minus game time end. And actually, it's going to be equal to the absolute value of it. So we make sure it's not negative. And ABS is the absolute value function. Okay, there we go. And then let's see. We're going to say, now all we got to do is kind of the same thing. I'm going to copy this and paste it here. Text equals font dot render. I'm going to put here time, and we're going to convert the string of time left. Okay, what color are we going to do? Let's just do same color. How's that? And for screen.blit, let's make the X value, let's put it in the center. Screen width, integer divided by 2, not 3, 2. And Y value of 10, so it's going to put it on level with the score. I think that's going to work. I think. I guess we'll find out here in a second. Okay, what I got here? Hello Pygame, line 65, invalid syntax. All right, let's take a look at line 65. Aha. Notice I've got 1, 2 opening parentheses, but or 1 opening parentheses, but 2 ending parentheses, and that's because screen width, or excuse me, the XY location should be enclosed in parentheses. Okay, now let's try it again. Oh, we got another error. Let's see here. Game time end is not defined. Game time end is not defined. Okay, let's take a look at line 63. So obviously, let's see what we got. Game end time. Game end time. Not game time end. Game end time. Okay, draw screen, game end time. Alright, let's take bets as to whether this is going to work this time or not. I think it's going to work. I've got confidence. There it is. Alright, perfect. It's working. So we're counting down. But you're going to notice that's a lot of decimal places. Let's round to 1 decimal place. I'm going to show you how to do that. So what we can do here for time left, there's a function called round, and it will round a number. So let's round time left to 1 decimal place. So what the round function does, it takes a number, a floating point number, in this case time left, and it rounds it to this many decimal places. So in this case, we're going to round it to 1 decimal place. And so what we've done here is we're saying, hey, our variable time left, let's set it equal to the result of this operation right here on the right. Let's run it one more time. So there we go. That's perfect. Our score is 1, 2, 3. Perfect. And once again, it is going to print out my score, my final score right there. Okay. Last thing we're going to do is we're going to do something with graphics. And in the interest of time, I downloaded a couple little icons. I'm going to show you where I got them. And so they're in my coding directory. I think this is Hello Pygame. Right. So I downloaded a little image icon of a mouse. And there he is right there. Whoops. All right. So mouse and cheese. There's my mouse. And there's my cheese. And I'll tell you where I got them. I got them from a place called flaticon.com. So I just went over here to Flat Icon. Got the caps lock on. Flat Icon offers some free graphics. So I just searched for mouse, pressed enter. And then I set my filters over here because not all of them are free. So I set filters and I said I wanted free only. And then I found one that I liked, which was this guy right here. I downloaded it. So I clicked on here. I said download PNG. I wanted it as a PNG file, not an SVG. So I downloaded it, but then the image was huge. It was 512 by 512. Now, if you remember, our images or our circles have a radius of 20, which means that they're actually 40 across. So what I did, I'm going to exit out of here, was I used a graphics program on the Raspberry Pi called GIMP. So over here, graphics, there it is. GNU Image Manipulation Program. If you want to install it, it's really super simple to install. You just do sudo, superuser do, apt get install GIMP, G-I-M-P. I've already got it installed, so it's going to tell me it's already the newest version. So then what I did was I started up GIMP. I did file open, went to my downloads directory, Pi, that's my username, downloads, and right there it is, mouse.png. You're going to notice it's quite large. It's 512 pixels across, but I only want it to be 40. Because remember, our radius is 20. So from the center to one edge of our circle is 20. So 40 across. So I just come over here to image, scale image. I'm going to scale it by pixels. So now it's 40 by 40. I click scale. So now it's nice and small. Then I'm going to come over here to file, export. Export, not save. Export as. Then I went to my coding directory, and so I clicked on Pi, clicked on coding, double clicked, and this is called Hello Pygame, and then I saved it as mouse.png, and I clicked export. It's already there. I'm going to replace it. That's fine. Take the defaults. It's fine. Just click export. Okay. And I did that for the cheese. I'm not going to go through it either. Or again, you can do that on your own. All right. So now what I have to do is I have to load these images. And I'm going to do that in the very, very beginning. When I set up my actor variables and constants, I'm going to load into here the images. And so the way we do that in Pygame, so I'm going to come over to here and I'm going to say, unfortunately I called it ball and not cheese in the beginning. I'm going to keep it that way. I'm going to say ball icon equals Pygame dot image dot load, and let's see here, this is the ball, so it's actually the cheese. So this is cheese dot png, which is what I named it. And I need to do the same thing for the player, and so I'm going to call this player icon. I could call it player graphic, I could call it mouse, I could call it whatever I wanted to. I'm going to call it player icon. Pygame.image.load, and I think I called it mouse.png. Okay, so now what I want to do up here where I draw and draw scene, I don't want to draw this anymore. Okay, I don't want to draw the circles. I want to actually draw the image. And if you remember, we've got the screen.blit function. We're going to use the same screen.blit function. So we're going to do screen.blit. And so this is drawing the ball. So I think I called it ball icon. I did. And we need the X and the Y, which was ball X and ball Y. Okay, I'm just going to copy and paste this because it's going to be very similar to draw the player. The player was, I think, player icon. And that's going to be the only change, is changing player icon and player X and player Y. Player icon, player X, and player Y. All right, let's run it. Oh, I got a error. Invalid destination position for bullet. Line 57. Let's see here. Ball icon, ball X, ball Y. I'm not seeing anything wrong with this. Not seeing anything wrong. Oh! Okay, yeah, all right. Now I do. Once again, I told you a long time ago at the beginning of this video this was a common error. I need to enclose the X and Y in parentheses. It's expecting a what's called a tuple or a tuple. Now let's try it. There we go. And hey, we're a mouse and cheese. All right. You're going to notice a couple of things. The collision detection no longer works perfectly. And that's because we were doing our collision detection off of a circle, which referenced the center of the circle as the as its coordinate system. In Pygame, for the rectangle, the coordinate is actually the upper left-hand corner of the image. And so our collision detection isn't working properly. Well, let's change that. So up here in detect collisions, we no longer need any of this stuff right here. All we really need to realize is that we have two rectangles. Okay, our images are two rectangles, 40 pixels across and 40 pixels high. Pygame actually has a collision detection built into it for rectangles. It will tell you if two rectangles have collided. But what we have to do is we have to get a rectangle object. I'm going to show you how to do that. Player icon dot get rectangle, and then mouse rectangle equals ball icon. If I'd planned this out better, I would have named my variables better. Ball icon dot get rectangle. So now we can tell if both of these rectangles, there is a function called player, what is it? Collide rectangle. There we go. All right, let me erase all this. So what we're going to say is if player rectangle dot collide rectangle, mouse rectangle. Okay, so here's the way this works. Each rectangle object has a method or a function called collide rectangle. And what you do is you pass to it another rectangle object. And it will tell you either true or false whether those two rectangles collide. Now we're going to run this and it's not going to work. Okay, it's not going to work. Then I'll tell you why. All right, so if you'll take a look, they're always, look at that score. That's amazing. It thinks it's always colliding, despite the fact that they're clearly not. And here's the reason why. We actually have to tell it the coordinates for the upper left-hand corner of the rectangle. And so we're going to do that by doing this. Player rectangle dot top left equals player X, comma, player Y. So what this is doing is it's setting the coordinates for the top left of the rectangle, the top left of that image, that icon, to be the player X and player Y, because that's where we've been drawing it. And we got to do the same thing for mouse rectangle. We have to set its upper left and upper right. So, or just its upper left, excuse me. Mouse rectangle dot top left equals ball X. And once again, I apologize for the inconsistent variable naming. I didn't know I was going to go in this direction when I started. Okay, now it should work, provided I have no other strange errors. Okay. And it's working. So my score was 2. Okay. That's pretty much the end. There are a couple of changes that you can make. Number one, it would be kind of cool if maybe each time the user caught the cheese, 1 second was added to their time. So the more times you catch the cheese, the more time that you get. So that'd be a change that you can make. If you need a hint for that change, if you don't want the hint, close your eye or your eyes, close your ears right now. But what you would do is down here, where we actually detect collisions, okay, and whether the collision was actually true or not, we reset the ball X and ball Y, okay. What could you do with the game time here? All right. The other change you can make is, let me run this. You'll see that because we used to reference the center of that circle, and now we're referencing the upper left corner, we can't get all the way to the edge. Let me run it again. We can't get all the way to the edge. And same thing over here, we go off halfway. Because we no longer need to, we're referencing our object a little bit differently. The circles were referenced by the center of the circle, whereas our graphics are referencing the upper left-hand corner. So you might change that so it's a little bit more consistent. And if you need a hint for that, I would check over here in our move game objects, where we actually check the player X and player Y, and same thing over here. Okay, well that's it. This is a long video, I know it was. I hope that you learned a lot. Please like the video, subscribe to the channel, I would really appreciate it. And until next time, well, first of all, if you have any questions about this, put them down in the comments, I'll try to get to them. But until next time, keep on coding, and goodbye.